In terms of Inky's mechanical design, Inky went through several mechanical iterations. It used to be square and boxy like this. Then we got feedback from the doctor before we landed on the design that is more curved. So I don't know fully what the mechanical process is for designing a structure, but at some point they also have to build their design in a 3D CAD software like this. And this gives us a 3D view of the design. It shows where screws go. You import sizes. You can mimic motion. So I know in some of our meetings, the mechanical team was showing us like how the doors will open, and you can do all kinds of stuff. They were even able to insert things that weren't a part of like the physical design of the incubator structure, like the bed that you can take in and out. You can see the power supply that we also take in and out at the bottom. You can see the hinges on the doors, the fan that also comes out and moves the heat around the system, the holes in the front panel where the buttons and the switches will go, and everything else that's important to the design. So it's a cool visualization of what our final product would look like. Once they finalized their design, they were able to get the acrylic and all the materials that they needed. And here you can see them laser cutting the circles for the doors. Those doors went through a lot of iterations too. They weren't always circular, but that's what we ended up with. You can see the holes that they cut in this video, and I think this is them describing how they glued the doors, but I'm gonna let them explain that.
That's epoxy and acrylic glue at the top.
What's epoxy?
It has like 2 different types of solvents or like chemicals, but when you mix them together, it makes it really hard to
Wow.
take apart.
You guys want acrylic glue against the PVC pipe?
Oh yeah, that was the thing. Here we have the electronics plate that housed all the electronics, so you can see where the Raspberry Pi microcontroller will be, the PCB, the fuse box. I think that's the ground plane. And we were able to slide this in and out of the system so we could easily access the components that we needed to test. And this is the power supply. You can see the plug that's used to power the entire system. And I think these were holes for the backup power supply. I had a really good time watching the mechanical team do their magic and understanding all the different components they needed and material choices. I didn't really understand a lot of it on a technical level, but it was cool to learn like the high level decision making process that they have to go through, because it's much different from the decision making process that the electricals go through or the softwares go through. So we wired up the front panel before we attached it to the system so we could make sure all the wires were clean and everything was going to the right location. And this housed all of the buttons and the knobs and the switches that someone will be able to use to control the system.
Couple of buttons, our speaker, the potentiometer that's going to control the temperature wherever the top of it is. I don't know. Oh, haha. So that's it for now. Cool.
We spent so much time in this room, to be honest, and in the lab, that I have no idea why I paid for a dorm senior year, because I was never there. This was the view that we had when we put the fan and the bed and the heating elements in. And at this point, it was almost complete and almost time to start testing.